The boot directory in Linux contains everything Linux needs to start or boot the system. If the boot directory is broken or missing, Linux will not start. That's how critical this directory is. Before Linux is fully running, the bootloader reads files from boot. Its job is to load the Linux kernel into memory and prepare the system to start. When we list our boot directory, we will see a few important files. One of them is vmlinuz. Vmlinuz stands for Virtual Memory Linux Unix Zip. This is the Linux kernel compressed to save disk space and memory. The number 6 represents the kernel version. You will also see a GRUB directory, which is the bootloader. It is the first software that runs and tells Linux which kernel to load. Proc is short for process. In Linux, the proc directory exposes live processes and kernel information as files. Windows does not have a single proc equivalent. Instead, the same information is spread across multiple tools and interfaces. Task Manager shows running processes and resources usage. Performance Monitor provides detailed performance counters. The Windows registry stores systems and kernels configuration. Windows Management Instrumentation or WMI allows program and administrators to query system internals. PowerShell commands like get process and get counter pull live system data using these interfaces. So while Linux exposes kernel internals throughout the process file system, Windows exposes them through tools, APIs, and commands. Just to let you know, the proc directory is a virtual file system created by the Linux kernel. It does not exist on disk. Instead, it provides a live view of what the kernel is doing right now. Everything inside proc is generated in real time. You can think of proc as a window into the kernel's brain. It contains information about running processes, memory usage, CPU details, and system configuration. Each running process gets its own directory inside proc named after its process ID. The proc directory also exposes system-wide information. For example, proc CPU info shows CPU details. Proc mem info shows memory usage. Many Linux commands like top, ps, and free actually read data from proc. So proc is not the storage, it's a live interface between user space and the kernel. Example of that could be cat, proc, and CPU info. This shows information about the CPU directly from the Linux kernel. And cat, proc, and meminfo shows how much memory the system has and how it is being used. Now let's talk about sbin. The S in sbin stands for system or superuser binary. Just as we have discussed in bin, sbin also contains binaries. But these binaries are meant for the system administration, not regular users. Commands inside sbin are used for things like starting or stopping services, managing disks and file systems, configuring the network, and system recovery and repair. Examples include mount, fsck, reboot, and ipconfig. By default, regular users cannot run most sbin commands. Only the administrator or the root user is supposed to use them. So in simple terms, bin is the essential commands for everyone using the system, while sbin is the essential commands for system administration.